Let's take a look at the Power Civil site drainage and kind of get familiar with some of the drainage components. Turn to page 1-1, and during this time together we're going to be creating a drainage project, and inside that drainage project we'll be adding and modifying components. Components of a Power Civil drainage project are nodes. Those would be catch basins and curb inlets and outlet structures. Links, those would be pipes, and that would be a path from node to node. And then networks. Network would be a series of inlets connected up through pipes or links flowing to an outlet structure. We also have a component called area. An area can be a closed boundary put into the design file via like a shape. But an area is simply where we calculate the runoff or Q and associate that Q or that area to a particular node. So a node and an area go together. There's a one-on-one relationship there. And as you see as we put them in, they actually have the same name. I'll have a node A1 and an area A1. So I know that the water collected in area A1 flows to node A1. And we can perform the necessary capacity calculations and spread calculations for that node. Areas are, the runoff for areas are calculated via the rational method or SES. Furthermore, another component of a drainage project would be a profile. And as it says there, a profile is just a representation of a profile representation of going from one node to another. So the user can choose, I want to cut a profile through node A1 to A10, and we'll find the shortest path and show you the profile. Any crossings, hydraulic information like the hydraulic grade line will be shown, ground profiles, both proposed and existing, will be shown. Any other utilities like water and sewer utilities or miscellaneous utilities, electric and cable could be shown as well on a crossing. All these components are stored within the drainage project. A drainage project has a specific extension. It has a GDF extension, GeoPack drainage file. A drainage project can have as many networks in it that it wants. So you can have multiple networks within one project. And each network can consist of as many nodes and links as you want. So there's no limitation on the amount of nodes and links that you can store within a drainage project. As I said before, computation is all done via the rational or SES method for runoff. And then we basically follow the standard federal highway methodologies for calculating pipes and nodes and capacities and stuff like that. We support a variety of inlet types, curb inlets, slotted drain inlets, grate inlets, and we can run calculations on each of those. Bypass flow is taken into account for inlets, and inlets are assigned further downstream bypass flow from another inlet. As you can see here on page 1-3, we have kind of a basic design workflow that we're going to follow in the Power Civil drainage. First step is to kind of design our surface collection system. So we'll go through and create our drainage areas. We'll assign nodes or create nodes for those areas. Once we lay that out, then we'll go ahead and connect them up via the links or pipes. We'll create an outlet structure, and then we'll go through and design the system. Once the system is designed, then we'll analyze it, review it, analyze it for different storm events maybe, edit it if necessary if we have any problems, profile through it and check the profiles of the system, basically evaluate its design. So in the first portion of this course, we're going to basically be setting up areas and nodes. Second step would be to connect those nodes up with pipes, and then we'll move into designing the system, where drainage, Power Civil drainage, will actually size the pipes for us, calculate the pipe capacities and flows and slopes and velocities, so that we can better evaluate our system. So I want to go ahead and start Power Civil and open up our main drainage design file. In this design file, we have laid out the basic site plan, and we're going to apply the drainage to this site plan. So open up a file called Site Plan DGN. That's located in my Data Geosite Drainage folder. So we're just going to do a simple drainage design on this parking lot and the access road coming into the parking lot, and evaluate that system